Welcome all. We have initiated the first chapter of this subject, that is mobile computing and communication. Today we will start with the third topic of this chapter, that is electromagnetic spectrum. So let us start with this electromagnetic spectrum. Here actually two words are there, electromagnetic and spectrum. Spectrum is nothing but classification or division or distribution. Just like single class is there of 60 students, we can distribute the students into girls and boys. In this way, spectrum is work, spectrum works, and electromagnetic is what? We know that all the cell phone devices uses wireless architecture to communicate. And in wireless communication, all the information get transmitted and received according by using waveforms. And waveforms are made up of what? Waveforms are made up of photons, vibrations. We know this. We know that different waveforms are there which travels through the air, carries information. But can this possible? Is it possible to carry information by every kind of waveform? Means if we are using cell phone, if cell phones are using waveforms, microwave ovens are also using waveforms, satellites are also using waveforms. So can all these three devices using same waveforms? Definitely not. Waveforms get changed according to its applications. Sometimes we need higher frequency waveforms. Sometimes we need lower frequency waveforms. Sometimes we need uh, waveforms with the high wavelength. Sometimes we need narrow wavelength in the waveforms. So according to its applications, the nature of the waveforms got changed. Hence, all the distribution system, all the distribution of the electromagnetic radiation get uh, divided in according to its wavelengths or according to different sets of frequencies. All the electronic waves traveled at the speed of light. But what is difference in all the waveforms? All the waveforms differs with respect to their frequencies, their wavelengths, their photon energies. Hence, we can say the distribution of electromagnetic radiations as subranges, means a range of frequencies, subranges of frequencies, portions of the frequencies, set of the frequencies. Just like visible light is having some set of frequencies, radio waves are having their own set of frequencies. No? So here we are talking about frequencies for radio transmission. Okay. What are their different frequencies that will be used for radio transmission? Now understand this thing first. What are there will be frequencies which will be used for radio transmission? Means what? Transmission in the radio. Radio means air, and if information is get transmitted through air, what are the set of frequencies information uses? Frequency can range from 30 Hz to 300 hertz to 300 terahertz, means hertz, then kilohertz, then megahertz, then gigahertz, then terahertz. So range of frequency radio transmission uses is from lowest is 300 hertz to highest is 300 terahertz. Okay, some concepts we need to understand before starting this is wavelength. Here is the example of wavelengths. If we start to counting any wave from this red line, then this waveform here, it completed its one cycle, and the length of this wave is called as wavelength, means length of this x-axis is called as wavelength, which is denoted by lambda. I'm trying to write a lambda here, lambda. Okay, so wavelength. After wavelength, what is frequency? Multiple times students faces difficulty in differentiating between frequency and wavelength. Now understand, calculating complete one cycle is called as wavelength. It is its wavelength, means lambda. Okay, and in a specific time period, how many waves are completing its one cycle? How many cycles of waveform is getting completed is called as its frequency. Okay. Means in unit time, let's take 1 second. 1 second is the unit time, and if five frequencies, sorry, 5 cycles of frequencies are completing in 1 second, it means it is having 5 hertz frequency. If 1000 cycles 1000 cycles are completing in 1 second, it means it is having 1 kilohertz frequency. Okay, it is frequency. And what to do if we want to calculate wavelength of waveform? We can calculate by using this formula. Wavelength is equal to, wavelength can be calculated by dividing the speed of light in vacuum, that is c, by the frequency of that waveform. Okay, it is the formula of calculating wavelength or calculating frequency of the waveform. Here the thing need to understand is wavelength is inversely proportional to frequency. Means what? If we increase wavelength, frequency will decreases. If we decrease wavelength, frequency will increases. We can understand this thing here. Let's take an example that this is the unit time t1, t2, t3, t4, and here in unit time only half cycle is completed, but in t4 1, 2, 3 cycles are getting completed. Here frequency is 3 hertz, and here frequency is half hertz. Why? because its length of cycle is bigger. Its length means lambda is bigger, and here its length means lambda is less. It means what? If we reduce wavelength, frequency increases, and if we increases wavelength, frequency decreases. I'm referring John Schiller's book of mobile computing and communication. The image is taken from this same book. Here we can see frequency spectrum ranges from 300 Hz to 300 terahertz. Now classes are low frequency, mid frequency, high frequency, very high frequency, ultra high frequency, super high frequency and extremely high frequency, infrared frequency, visible light and ultraviolet frequency. As we go from left to right, frequency increases, means wavelength decreases. We can see here in very low frequency, the frequency range is from 300 to 30 kilohertz. In low frequency, we can see the frequency range is from 3 kilohertz to I think 300 kilohertz something is there. In low frequency and in low frequency, the frequency range is from 330 kilohertz to 300 kilohertz. In low frequency, not in very low frequency. In low frequency. In mid frequency and high frequency, frequency ranges from 500 to 150 megahertz. 500 kilohertz to 150 megahertz. In what? Mid frequency and high frequency. In ultra high frequency and very high frequency, frequency ranges from 174 megahertz to 800 megahertz. For TV stations, means the television we see. For digital audio broadcasting or digital video broadcasting, frequency ranges from 230 to 1500 megahertz. And for GSM communication, frequency ranges goes up to 2200 megahertz. And in case of super high frequency and extremely high frequency, just like using microwave, frequency ranges from 2 gigahertz to 40 gigahertz, and for satellites it goes up to 30 gigahertz. You can see here infrared uses the range from I think 1 terahertz to 200 terahertz. It is the range of infrared, and visible light using frequency more than this, and largest frequency used by ultraviolet rays. Here we can see few examples of electromagnetic radiation. We can see here a radio and microwave is using the frequency infrared, visible light, ultraviolet, X-rays, gamma rays. We can see here the frequency ranges in increasing order from left to right. Maximum frequency is used by gamma rays, and minimum frequency here is used by radios or television. Thank you.